What is a function? A function is some rule for the relationship between an input and an output. Typical function notation is y equals f of x, which is the one that you're probably the most familiar with. There's also y equals g of x and y equals h of x. Now, typical format is output equals f input, where the input is our independent variable, while the output is our dependent variable. One thing to remember with the definition of a function is that each input has exactly one output, meaning each x has one y. Now, let's solve an example problem that helps us to understand function notation more. The amount of waste G is produced by a city with a population P is given by G equals F of P. G is measured in tons per week, and P is measured in thousands of people. The town Oz has a population of 74,000 and produces 18 tons of waste each week, expressed in terms of the function f. So here we're given the function notation, which is G equals F of P. We're also told that G is measured in tons per week. And what's measured in tons per week? The amount of waste each week. So we can go ahead and sub in 18 for G. And we're also told that P is measured in thousands of people. And what's measured using the unit of people? The population, which is 74,000. And this equation reads as 74,000 people produced 18 tons of garbage. Another way to look at this problem is by going back to the previous slide, remembering that y is our output. Well, g would be our output for this equation. And just looking through the problem and looking for any keywords that signify output. And in this case, it would be produces. So that's another way we can figure out to sub in 18 for G. In order to determine whether a relation on a graph is a function or not, we have something called the vertical line test. In order to perform this test, you have to draw a vertical line through your relation. And if your vertical line hits only one point on your graph, then it is a function. But if your vertical line hits more than 1 point on your vertical line, then it's not a function. And we can see in this example below that the relation hits 3 points on our vertical line. Therefore, this is not a function. Now we're going to determine which tables represents functions. Remember earlier when I mentioned that each x has one y? We're going to use that to determine which tables represent a function. So looking through the first table, we see that each x has one y. Therefore, this one is a function. Now, we see for table 2 that we are given f of 1 equals 2 and f of 1 equals 5. So that's one x value that outputs two different y values. Therefore, this one is not a function. So f of 1 equals 2, f of 1 equals 5. And now for table 3. We see that still each x has one y. So therefore, this one is a function. But something that might trip you guys up is f of 2 equals 1 and f of 5 equals 1. We see that we're given two different x values, but it outputs the same y value. Therefore, this one is a function. Now for the last table, we see that f of 2 equals 1 and f of 2 equals 15. So we see that we're given the same x value, but we're given two different y values. Therefore, this one is not a function. Now we're going to use this graph to evaluate for f of 2 equals blank, and we're also going to solve for f of blank equals 4. So before even attempting this problem, try to get into the habit of testing whether or not the relation you're looking at is a function or not. And remember, we test that with our vertical line test. As we can see, the relation only hits 1 point on our vertical line. Therefore, this is a function. Now, moving on to the problem. We're given the x value for f of 2. Now we just have to find our y value. So we go on the x-axis and we find number 2 and we plot that point that hits the relation. And then we look on our y-axis and see what points that hits. And we hit number 1. For the second problem, we're given the y value, but we have to find our x value. So just go on the y-axis and find 4. And then branch out to the x-axis and find where it hits the relation. And we see that we hit two different points. So The answer is x equals -1 and x equals +3. Now, after determining if a relation is a function, we can then determine if the function is one-to-one, which means one input per output. I mean, yes, one output per input. In order to conduct this test, remember, you must first check whether or not the relation is a function. So you'd want to perform the vertical line test and check that the relation is a function. And then after verifying, now you can conduct the horizontal line test. It's just like the vertical line test, only this time you draw a horizontal line. So if your horizontal line only hits one point of your relation, then your function is one-to-one. But if it hits more than 1 point on your horizontal line, then your function is not one-to-one. Now, let's take a look at these three examples. First, we're going to check if it's a function. Okay, it passes the vertical line test. Now we can move on to our horizontal line test. We see it only hits 1 point on our horizontal line. So it passes the vertical line test, so we know it's a function, and it also passes the horizontal line test. So we also know it's one-to-one. Moving on to the second example, testing if it's a function first. We see it passes the vertical line test, so we know it's a function. And now we do the horizontal line test, but it hits 2 points on our horizontal line. Therefore, we know that this failed our horizontal line test. Therefore, this function is not one-to-one. Now, for the last example, we test if it's a function and we see it hits more than 1 point on our vertical line. We see it hits 3 points on our vertical line. Therefore, this one fails the vertical line test, so not a function. And now we're gonna determine which tables represents a function and are also one-to-one. So remember, for a table to be a function, each x must have one y. And we also know to be one-to-one, it's one output per input, so one x and one y. So for the first table, we see that each x has one y, and we also see that for every x value, there's only one y value. Therefore, this one passes, and it's a function, and it's also one-to-one. Now, for the second table, we see that our x value has two different y values, so one x and two y's. That's f of 7 equals 6 and f of 7 equals 15. Therefore, this one is not a function, so we can't even check if it's one-to-one because it's not a function. And now for the last one, we see that each x has one y. But we see here for f of 7 equals 6 and f of 12 equals 6 that we are given two x values but one y value. So therefore, this function is not one-to-one. And that was for f of 7 equals 6, f of 12 equals 6. So this is 2x and 1y. So not one-to-one. To wrap up this video, we're going to summarize everything we have learned so far. So, we know that a function is a rule for a relationship between the input and output value. And a functional relationship is described as one which the outputs can be determined from the inputs. And in order to determine whether or not something is a function or not, for a graph, we must perform the vertical line test. And remember, if the relation only hits 1 point on our vertical line, then that relation is now a function. But if it hits more than 1 point on our vertical line, therefore it's not a function. And then to determine if a table is a function or not, remember each x value must have only one y value. And then after verifying if the relationship, if the relation on the graph is a function, we can then move on to determine if the function is one-to-one or not. And remember, for a graph, we perform the horizontal line test. But for a table, we just make sure that every x has one y value. So one x value for, or let's reword this as one x value must only have one y value. And that was all about functions for now, but in the next video, we will explore the different graphs of functions.